This video goes through the review sheet for the Piecewise test in advanced functions and modeling. So first we have a question that says state the domain of the relation 6, -4, 3, -4, 7, 1, and 12, 3. Remember, domain is all the x's, so the domain would be 6, 3, 7, and 12. Now you don't have to put them in order, but that's usually how people do it, so we'll do 3, 6, 7, and 12. And just so you know, in case they do ask for the range, I know they did not on this problem, but in case they do on the test, the range is the y values. So that would be -4, -4, 1, and 3. Just because -4 shows up twice doesn't mean you need to put it twice. You can just put -4, 1, and 3. Second, determine whether the relation is a function. Now when you're looking at a set of ordered pairs and you're trying to figure out if it is a function or not, all you need to do is look at the x values. So I'm only focused on the x values. If any x values repeat or are duplicates, it's not a function. If they're all different, then it is a function. So as we look at this problem, we see, no, it's not a function, because we have duplicate x values. -2 shows up twice. So if all the x values are different, it is a function. If you have any duplicates, it's not a function. Next, determine whether this equation defines y as a function of x. This is also simple. You just need to look at your y, and as long as y does not have an even exponent, such as y squared, y to the 4th, y to the 6th, then it is a function. So this, yes, it's a function. So you want to look at the y. Y is all that matters. There may be more than one, but you only look at the y's. And as long as y isn't squared, to the 4th, to the 6th, or any even exponent, then it's a function. If y is squared or raised to the 4th or anything like that, then it's not a function. This says evaluate the function if the given values. Whatever is in parentheses, you plug in for x. So I'm plugging everything into this function. So f of 2 will become 2 squared plus 3 times 2. So we get 4 plus 6 equals 10. Okay, again, whatever's inside the parentheses, you plug it in for x. 3a squared, 3 squared is 9, a squared is just a squared, and then 3 times 3a is 9a. Then this last one, part C, we have to plug in x plus 3 everywhere we see an x. Now to square x plus 3, we have to FOIL. You can't just square x and square 3, because squared means times itself. So it's x plus 3 times x plus 3. So when you FOIL that, you get x squared plus 3x plus 3x plus 9. And then 3 times x, 3 times 3 is 9. Then you just combine all the like terms. X squared is the only squared. 3x plus 3x plus 3x is 9x. And 9 plus 9 is 18. And some of you have asked if you need to factor that. No, you definitely do not need to factor that. You just leave it just the way it is. Just make sure you combine all the like terms. Alright, now we have a piecewise function where we're supposed to evaluate. We look at this part over here to tell us where we should plug in these numbers. For example, in this first one we have f of -3. Well, you just ask, is -3 less than 1 or greater than or equal to 1? Since it's less than 1, we would plug it in the top equation and do -3 squared minus 3 times -3. So that gives us 9 plus 9, because two negatives make a positive, and we get 18. F of 1, okay, so we go over here and we say, well, 1 is equal to 1, so we put it with the bottom equation this time. 6 times 1 plus 1 is 7. And then finally, we're supposed to plug in 3. Well, 3 is clearly greater than 1, so we use the second equation. We get 6 times 3 is 18, plus 1 is 19. So use the parts on the right to figure out which equation to plug it into, and then just plug in your number for x in that equation. Number 6, graph the following on the plane below. Do it by hand, then check in your calculator. There's actually a typo here. I just want you to do it in your calculator. So let me show you how to plug these in. So let's go to y equals. Clear out what we have, turn off that plot. And I need to do parentheses 2x plus 1, close parentheses. So I take my equation, 2x plus 1, and put it in parentheses. Then I do divided by parentheses x, and then to get that less than or equal to, I have to go to second math. And you see less than or equal to is the sixth one. So I do x is less than or equal to 2, and then close the parentheses. Now to plug in the second half, I need to do the second equation in y2. Parentheses, negative 3x plus 8, close parentheses, divided by parentheses, x is greater than, again, for those you go to second math, it's where it says test, greater than is number 3, 2, close the parentheses. Then I'll just go to my graph, and I'm zoomed out real weird, so I'm going to hit zoom 6, put it back to normal, and there's my rough sketch. So I would just want you to be able to draw something like this, and that would be enough. If you want to get real good, then you would put a closed circle here because of the greater than, less than or equal to, and an open circle here because it's just greater than. And if you notice, the direction these arrows point, the less than, for example, shows you which direction their pieces point. Number 7, a band named So's Your Face charges $200 for a show lasting up to a half an hour, $300 for a show lasting up to 1 hour, $500 for a show lasting up to 2 hours, or you can rent them all day for $1,000. Write a piecewise function that expresses what the band charges. Well, here, let's do it this way. List all the different charges the band has. That's either $200 or $300 or $500 or $1,000. Those are the 4 different charges that I might be charged for hiring this band. Now for the $200, the show can last up to a half hour. So I'll just use, I'm going to use hours. So I'm going to say anything between 0 and 1/2 costs me $200. So if my show lasts anywhere between 0 and 1/2 an hour, then it's $200. Now $300 is what I get charged if the show lasts up to an hour. So I would get charged $300 if I go over a half hour up to 1 hour. And then $500 can get me up to 2 hours. So anything over an hour up to 2 hours is worth $500. And then $1,000 is anything over 2 hours. And you can, if you want, you can say 2 is less than x is less than or equal to 24 since there's only 24 hours in a day. But I'd also be fine with just doing x is greater than 2. Either one of those would be fine. So the key is to list all the charges and then show the range where those charges would be applied. Alright, the table at the right displays the average cost of the monthly premiums for health care in the United States in years after, and I corrected this on your sheet, but it should say the year 2000. Use the table to answer the following questions. Using the data from year 200 and the year 2005, write an equation of a line that could be used to model this portion of the data. So they're telling me to use this point, because that's 0 years after 2000, and that's 5 years after, so that's 2005. I have the ordered pairs 0, 426, and 5, 530. And notice it doesn't say those years through those, it just says use those 2 years. That's why I'm just using those 2 points. So now I'm going to use the slope formula to find the slope between those 2 points. 530 minus 426 is 104 over 5. So that's my slope. And then if you look, this is actually my y-intercept already, because it's at when x is 0, that's your y-intercept. So my equation would be y equals 104 over 5x plus 426. Now just so you know, if you want to use the decimal instead of 104 over 5, I think it should be 20.8, and that's completely fine. The decimal or the fraction, either one works. Okay, so that's all of part A. Let's move on to part B. It says using the data from the year 2005 and the year 2009, write an equation of a line that can be used to model this portion of the data. So let's go back. 2005 was 5,530. And 9 was 9,670. 670 minus 530 over 9 minus 5. It's going to give me 140 over 4, which is, let's see, 35. So this time my slope is 35. So I'm going to use the point slope form and do y minus 530 equals 35 times x minus 5. So I get y minus 530 equals 35x minus 35 times 5 is, I think, 165, 175. There we go. And then I add 530 to both sides and get 355. So my equation turns out to be y equals 35x plus 355. Now C says, using the data from the year 2000 and 2009, write an equation of a line that can be used to model all of the data. So we've done it in two pieces so far. Now we're going to do it as a whole. So 2000 was 0, 426. And then 9 we have right here. That's 9, 670. So let's do the slope formula. 670 minus 426 over 9 minus 0. That's going to come out to 244 over 9. Which is 27.1 repeating. So that's my slope, and like I said, we already know this is our y-intercept. So we'd have y equals 27.1 repeating x plus 426. Now, part D. In the year 2011, the average monthly premium was actually $732. Does your equation from part B or part C model this more closely? So let's look. I'm going to plug my answer from part B and part C into my calculator in y equals. So 35x plus 355. That's what I got in part B. Part C, I got 27.111111. That's enough, close enough. X plus 426. Now, we want to know what it would be in the year 2011. So remember, this was years after 2000. So we'd go to our table and plug in 11. So part B gives us the answer 740. Part C gives us the answer 724. And it says the real number was 732. So it looks like both of these actually were pretty close to 732. So in this case, both of them would work. If you look, they're both exactly $8 away from the real thing. Now I'll go ahead and tell you, on your test, it's not going to be that close. One of them is clearly going to be closer to the answer than the other. So just make sure you compare those numbers, because that's all we're trying to do. We're trying to see, does splitting up the data into pieces work better than doing the whole thing? In this case, it really didn't. They were both about the same. One just guessed a little over, one guessed a little under. So in this case, splitting the data and making a piecewise function really didn't help. But I promise you, the one on the test, one of the two will work better, either splitting it up or using the thing as a whole.